Hello again, back here with Unit 8, Lesson 2, Factoring Using the Greatest Common Factor. So this follows a little bit of what we began to discuss last lesson, but we'll get a little deeper into the idea of greatest common factor here in this lesson. So first of all, really, what is the greatest common factor? And it's the greatest value that will divide two numbers. So for instance, when you look at the values of, like, say, 15 and 25 here, you look at what are the factors of each. So for 15, the factors would be 1 and 15, 3 and 5. And you look at the number 25, you've got 1 and 25, 5 and 5, and so just 5 is a factor. So as you can see here, 1 obviously is one of the factors, but 5 is the greatest common factor between these two. Similarly, you look at 12 and 4. For 12, you've got 1, 12, 2, 6, 3, 4, and naturally, for the number 4, you've got 1 and 4. Now, just to dive a little deeper on this, what that really means is that you would divide each of these by 4, and then you'd really just have the 4 on the outside, and what's left of these would go on the inside. So it'd really be a 3 and a 1 and whatever that was, plus or minus or times or whatever, multiplied. But that 4 would come out then as the greatest common factor. And you'd see that a little more here on this third one. So first of all, numerically, for the numbers, we've got 1 and 6, 2 and 3 are factors of number 6. We've got 1 and 9, and then 3 and 3 or 3 for the 9. And so as we look at that, we see that 3 is the greatest common factor, but then they also each have an x. Obviously, the 6 has 3 x's multiplied by each other to get that x cubed, but they each have at least one x since this one only has a single x. So what we really are pulling out here is actually a 3x. And then what's left is what's 6 divided by 3? Well, that's 2. And then there's, again, still x squared there because we only took one of the x's out. So again, x cubed over x is the same as x to the 3 minus 1. Okay, so that's the same as that. So that left an x squared there. And then this 9x, when we divide it by 3x, the x's are gone, again, because x to the first over x to the first is really x to the 1 minus 1, or x to the 0, which is 1. So this is 3 would be the other term there. And as you can see, if I were to distribute that 3x back, 3x times 2x squared would be 6x cubed, and 3x times 3 would be 9x, which was, of course, our original values up there. Now just looking at a collection of polynomials here and just factoring out greatest common factor for each. And so we look at this first one, we can see that there's not an x in both, and so we're just factoring out numbers. So as we think about this, we know that 3 and 8 are factors of the first term, and obviously 8 is the second term, so 8's going to be your greatest common factor here. So we would write this then as an 8 on the outside, and then we'd put up here, okay, what's 24x divided by 8? Well, that's 3x. And what's 8 divided by 8? Well, that's 1. And so that would be 8 on the outside. And again, we could distribute. There's a 24x. And distribute. There's a positive 8. So you can see that that's the correct answer. Next one here. Again, there's only a y in the first term. So it's really about 4 and 8. Well, we know that 2 and 4 are factors of 8. So 4 is going to be our greatest common factor here. So we're going to pull a 4 out. And then look at, okay, 4y divided by 4 is just y. And then a negative 8 divided by 4 would be a negative 2 or a minus 2 for that. So again, that 4y minus 8 would bring us back to the original term. Now looking at the third one, you can see there's y's in each of these. Okay, so obviously it's y squared in the first, but there's only a single y in the second. And then looking at the greatest common factor, we talked about this already, that for 6 and 9, the greatest common factor will be 3, because the only options there are 1, 3, and 9 from 9, and then 1, 6, 2, and 3 from the 6. So what we're going to do is we're going to divide each of these by a 3y. So the 3y will come on the outside, And so 6 divided by 3 is 2. Y squared divided by y is y. Again, y squared divided by y to the first is equal to y to the 2 minus 1. That's the exponent rule there. And then on the other, the y's, again, we take care of each other. So it's just the 9 divided by 3, but it was subtraction again. So 9 divided by 3 is 3. The subtraction stays in there. And again, you can see if we were to distribute, we would get back to our original 6y squared minus 9y. Couple more here. Let's see. We look at this one here. You can see they each have an x in them. One has an x squared. And then naturally 2 and 7 are factors of 14. So if we divide both of these by 7x, what that would give us then is a 7x on the outside. 14 divided by 7 is 2. X squared divided by x is x. And then 7x divided by 7x is just 1. So that would be a plus 1. So again, 7x times 2x is 14x squared. 7x times 1 would be 7x. And looking at our last one here with this 30n squared minus 45n. Now these values, we know that they each have at least an n that we're going to divide out, but the values are a little bigger. It can be a few more factors, so we've got the 1 in 30 and the 1 in 45, but we'll just look at the ones that have a greater than 1 factor in each pair. So we've got 2 and 15, we've got 3 and 10, we've got 5 and 6. For the 45, we've got 3 and 15. So naturally, it looks like 15 is going to be our winner here, but we could go on and say we also have a 5 and a 9, and of course the 1 in 45 there. But we see 15 as a common factor here. So if we take a 15 in front of each of these and divide out that 15n, or factor it out, and now we'd look at 30 divided by 15 is 2, n squared divided by n is n. And then again here, n divided by n is a 1, and so that's gone. And so it's just a minus 3 here with the 45 divided by 15. And again, we could distribute that out to show that it ends up being the original term again. A couple more here that get a little more complicated, and we'll just run through these pretty quickly here. So the values 15 and 20, so looking at factors of those for 20, of course, it's the 1 and 20, 2, 10, and 4, 5. For 15, it's 1 and 15, or really 3 and 5. So we see that 5 is a good greatest common factor on the numerical side. They also each have at least one x, and they each have at least one y. So that's what they have in common in terms of the greatest terms that they have in common. And then we look at this, 15 divided by 5 is 3, x squared divided by x is x, y divided by y is 1, so that finishes the first term. On the second term, 20 divided by 5 is 4, x divided by x is 1, y squared divided by y is y. And again, distribute that out and verify as well. Now looking at the second one, this is a little more of a traditional term that we're going to see in terms of quadratic equation, and looking at factoring with a lot of this ax squared plus bx plus c, which in this case, of course, is y. But these are going to be important to be able to factor these 3-term polynomials. And so when we look at this, they don't all have y's, so we can't factor out a y value. But when we see that 4 is our smallest number, and 4 is a factor of the rest of them, we do see that 4 is going to be that value that we can pull out. And 16 divided by 4 is 4, so that's just 4y squared. 8 divided by 4 is 2, so that's 2y. And then 4 divided by 4 is 1. And you can see the value in this is it just makes the quadratic here a little easier to factor. Factoring a leading term where a is 4 is going to be a little nicer to work with than an a equaling 16. And sometimes, obviously, most ideal is if we can get the a term down to 1, or not being negative, things like that. So this is where using these greatest common factors is going to be really helpful to try and simplify the work for us. Looking at the bottom left here, again, there's not a w in each of these. But let's see, there's not a 9 in each, there's not a 12 in the 9, of course, and so we gotta get a little more creative. So 18 has a 3 in it, 9 also has a 3 in it, 12 has a 3 in it, looks like 3 is going to be our biggest term, because if you really look at the smallest number, which is 9, the only options there are 1, 3, and 9, and we aren't going to be able to divide out a 9 from that 12. So we take that 3 out of there. 18 divided by 3 is 6, so that's 6w squared. 9 divided by 3 is 3, so that's 3w. 12 divided by 3 is 4. So again, there we factored that a little bit using the greatest common factor, at least factored out the 3, and then we would go on from there to factor the rest. Finally, this last one, you can see that it's 1n cubed, so we aren't going to factor out any numerical value there, but we will factor out an n. So we take an n out, and that would just leave us with n squared minus 9n plus 2. And then from there, now we can see it'd be a little easier to figure out, okay, what value can be and so forth from there, and what are our zeros and things. So we'll leave it at that and move on now to some actual examples. So now looking at factoring and solving quadratics using this greatest common factor. If we look at a problem like this first one here, 3x squared minus 9x, and the factoring side of it, you can see naturally that 3 is going to be our greatest numerical factor out, and then there is an x to factor out as well. So we have 3x, and again, 3 divided by 3 is 1, x squared divided by x is x for the first term. 9 divided by 3 is 3. It should say minus or negative 9 divided by 3. It would be a minus 3. And x divided by x as is. And so when we look at this, actually, because of that factoring out the greatest common factor, this is our final answer. There is no second x plus or minus or 3x plus or minus. It's just a 3x on its own out there. So when we solve for the zeros ultimately, what we're saying is either 3x equals 0 or x minus 3 equals 0. So here, of course, when you divide by 3, x equals 0 would be one of our zeros. And when you add 3 to both sides, then x equals 3 is our other 0. So you can see the value of the greatest common factor. You have an a value that's 3 here, which tends to be more complicated. However, with the greatest common factor and pulling out that 3x, we turn this into a relatively simple problem. Another one here, you can see there's a negative in the first term. And again, if there is a negative in that first term, you make your life a lot easier if you get rid of the negative as well. So I'm going to actually put a negative there. Naturally, that will change this from a plus to a minus, but that's okay. It's makes our life easier if that a term is 1 again. So you can see that 2 is going to be the biggest factor that we can divide out here. And then we have that x as well. So when we write this, there'll be the negative 2x up front. And again, that means negative 2 divided by negative 2 is 1. X squared divided by x is x, so this is just x then. 12 divided by negative 2 is a negative 6, and again, x divided by x. So again, now our zeros would be negative 2x equals 0. So dividing by negative 2 means that x would be 0, or x minus 6 is 0. So adding 6 to both sides means that x would be 6 there. Again, just the negative piece here and factoring that out is what was responsible for making this x instead of making it negative x. And again, you'd still be able to solve it, but it would be just a slightly more difficult problem. So if you can factor a negative out as well, out of that a or out of that leading term, would recommend. Here we have one that now we have the a, b, and c terms here. So we can't factor out an x, but we do see that we can factor out a 2. So when we write this here, what's nice here is when we factor out a 2, now we have what we had last lesson, which is a good 3-term ax squared plus bx plus c, and the a is equal to 1 here. So what we've made that a little easier in that the 2 is going to be along for the ride here. But now what we want to do is factor just like we did last lesson. So we've got the 2 x's. And again, we're looking for something that multiplies to negative 20. So it multiplies to 20, but it adds up to 8. And so Again, negative 20 means it's going to be a positive and a negative. And we've got 1 and 20, and we've got 2 and 10, and we've got 4 and 5. And again, a positive 10 and a negative 2 here would add up to an 8, and would multiply 10 times negative 2 would multiply to that negative 20. And again, what made this really nice for us was to be able to factor out that 2, and so we could have that a value of 1 inside the parentheses here. And now again, we could verify our answer by coming back and factoring, or excuse me, distributing that 2 into the first term, and then actually foiling to move from factor to standard form. And we see first would make it 2x squared, outside would be a minus 4x, inside would be a positive 20x, and last would be a negative 40. Oh, sorry, there's an x there. And so you've got a positive 16x in the middle, which is what we had, and then the 2x squared and the negative 40 as the a and c terms. So that we know that we've factored that properly to get to this point here. So here's just another example with 3 terms again. Another situation where they don't all have x's, so we can't factor out an x, but we're going to factor out a 2 again. And so that leaves us with f of x equals a 2 out front, and 2 divided by 2 is 1, so there's our x squared. So that's our nice, comfortable leading term again. And then negative 2 divided by 2 just is a negative 1x in the middle, and then the negative 24 divided by 2 is a negative 12 or a minus 12 there. So to factor this again, the 2 is along for the ride. We know we're going to have an x and an x. And we know that because what they need to multiply to is negative, that one of these will be plus and one of these will be minus. And so we got to look at the number 12 here. And again, they need to add up to a negative 1. So 1 and 12 wouldn't work, 2 and 6 wouldn't work, but 3 and 4 would work. And again, because it's negative 1, the minus needs to be the 4, and the plus needs to be the 3. So when we FOIL that inside there, we'd get x squared minus 4x plus 3x minus 12. And again, we still have that 2, so we could last slide I factored the 2 in first by distributing. I shouldn't say factored in, that's misleading here now, but distributed that 2 in first, but just again to show that we had the negative 1 there. You can see it now. We could factor that 2 in as well here at the end. And so you can see that it's still the 2x squared. That's a negative 1x there. So 2 times the negative 1x is minus 2x and minus 24. It leads to the same result again of where we started. And again, I could have gotten that same answer by distributing that 2 in first and checking. But back to the original intent of the problem, of course, was when we factored that 2 out, now we had a leading term of 1x squared, and it made it easier to factor the rest of the quadratic. Now we take this step when we solve for the zeros, so we've got x plus 3 equals 0. So we know that x is negative 3 is one of our options, and we've got x minus 4 equals 0. So we add the 4 to both sides, so we've got x equals 4 as our other option. Final example here. Again, this is just factoring out the negative, and so when we if we were to just, they don't all have x's, they don't all have a common term, but if we just factor out the negative, you can see what that does for us here, because now that negative is out front, and again, you don't need to write negative 1, you can just put negative, and now we've got a positive x squared, a negative 7x, okay, because 7 divided by negative 1, and then a plus 10. So again, this just makes our life a little easier, because without having that negative term there, the factoring with the x squared minus 7x plus 10 becomes a little easier. So again, we're looking for 2 values that multiply to 10 but add up to negative 7. So again, they need to multiply to be a positive number. So we're looking, but add to be a negative, so we're looking for 2 negative values. Well, negative 1 and negative 10 is negative 11. -2 and -5 is -7, which is what we needed it to be. So for this here, we could rewrite this as -1, x minus 2, x minus 5. And again, if you were to FOIL that, you'd get x squared minus 5x minus 2x, which combines to minus 7x. And then -2 times -5 is that positive 10. And again, when you then multiply that by -1, then it would bring you back to this original, because that -7x would go back to positive, that positive 10 would go back to negative, and of course this negative would show back up for that leading a value again. So solving for our zeros here, we have x minus 2 equals 0, we have x minus 5 equals 0, so x equals 2 and x equals 5 would be our results. And again, it's the result whether it's here for the factored form. It would be the result whether it's here. All of this work isn't going to change what our x's are. It just makes it easier to find them. Thank you as always for listening, and if you have questions, please ask.